Good evening, dear students. Today we will learn about electric dipole and the electric field due to electric dipole at a point on the axis. Now, if you are new to my channel, please subscribe it and please watch this video till the end so that you understand the concept properly. अगर आप इस चैनल में नए हो तो आप पूरा वीडियो भी देखिए और सब्सक्राइब भी कीजिए ताकि आपको वो कॉन्सेप्ट ठीक से समझ में आए इलेक्ट्रिक डाइपोल का. ठीक है. सो नाउ फर्स्ट वी विल डिसाइड और वी विल डिफाइन व्हाट इज अ इलेक्ट्रिक डाइपोल. As you can see, dipole is a pair of opposite charges minus q and plus q separated by a distance of 2a, where 2a is nothing but the distance between the two charges. You can take it as L also. Fine. So you can see the combination or a pair of opposite charges plus q minus q separated by a distance is the dipole itself. It is just a combined system. Now, what is the center? The center of the line joining these two, that is the length 2a. Okay, line joining these two charges is called the center of the dipole. So, center of the dipole, as can be seen, is the center of the line joining the two charges. What is it? It is center of line joining the two charges. Okay, that is the center of the dipole. Okay, now this I am just giving you the features of a electric dipole. That is what I am trying to do now. It is a combination of two opposite charges separated by a distance 2a. The center of 2a, that is a, is the center of the dipole. That is the distance from the center to the charge plus q or minus q is a. That is the meaning here. Okay. Now I go to the another feature where how is it denoted? How can you denote an electric dipole? It wants a symbol. So the symbol of electric dipole is capital P. And if we want to know the direction, it can be written as P arrow, where the direction of electric dipole is always taken from negative q to positive q. Fine. So now I will mark it here from negative q to positive q. That is the direction of the electric dipole vector. Remember this also. Okay, this has to be remembered by convention. It is taken by convention. So the direction of the electric dipole is always from negative charge to the positive charge. Fine. Now, as can be seen in the diagram, it is a system of one positive charge and negative charge. So, and the magnitudes also are same. So, the total charge plus q and minus q are adding up and gets 0. So, for an electric dipole, the total charge is always 0. Okay. So, for a electric dipole, the total charge of the system, the total charge is always 0. So, what are we saying? If the total charge is 0, then where is the electric field? Is it there or is it not there? It is there. How? Because the electric field produced by each charge will not cancel each other completely at every point on the axis of the dipole. What is the axis of the dipole? The line joining these two charges is the axis of the dipole, and even this side or that side. Continuous line is the axis of the dipole. At every point on the axis of the dipole, the electric field is not going to be zero. That's why, though the total charge plus q minus q is zero, electric field due to an electric dipole is there. So इलेक्ट्रिक डाइपोल को हम हिंदी में थोड़ा सा रिवाइज कर लेते हैं. फाइन. ओके. सो इलेक्ट्रिक डाइपोल एक कॉम्बिनेशन है, एक पेयर है, एक जोड़ी है, एक पॉजिटिव चार्ज की और एक नेगेटिव चार्ज की, जिन दोनों में डिस्टेंस है 2a. ठीक है. सो ये जो कॉम्बिनेशन है प्लस q माइनस q और डिस्टेंस 2a का, उसको बोलते हैं इलेक्ट्रिक डाइपोल. ठीक है. चलो, अब सेंटर ऑफ इलेक्ट्रिक डाइपोल क्या है? सेंटर इज द सेंटर ऑफ 2a. तो यहां से A तक जो भी पॉइंट आया वो है सेंटर ऑफ द डाइपोल. सो O इज द सेंटर ऑफ डाइपोल, जिसका अंतर ये चार्ज से भी A है और ये चार्ज से भी A ही है. ठीक है. चलो, नेक्स्ट, इसको डिनोट कैसे करते हैं इलेक्ट्रिक डाइपोल को? इलेक्ट्रिक डाइपोल को डिनोट करते हैं P से. डायरेक्शन कैसे बताते हैं? P वेक्टर एरो. ठीक है. अब डायरेक्शन कैसे हम ड्रॉ करते हैं? तो माइनस क्यू टू प्लस क्यू. सो याद रखना है, इलेक्ट्रिक डाइपोल का डायरेक्शन हमेशा माइनस क्यू टू प्लस क्यू ही होगा. ये कन्वेंशन लिया है तो ये ही होगा. ठीक है. चलो, नाउ द टोटल चार्ज इज ऑलवेज जीरो. यहाँ पे देख रहे हैं, यहाँ पे भी देख रहे हैं, ये एक प्लस क्यू है, एक माइनस क्यू है, कट जाएंगे, आंसर इसका जीरो होगा. तो टोटल चार्ज इलेक्ट्रिक डाइपोल का हमेशा से जीरो होगा. तो इसका मतलब ये है कि अगर चार्ज ही नहीं है तो इलेक्ट्रिक फील्ड इस कॉम्बिनेशन का होगा? जरूर होगा. क्यों? क्योंकि ये जो दोनों चार्जेस है, इन्होंने इलेक्ट्रिक फील्ड बनाई है अपनी अपनी. जैसे कि हमने पढ़ा है, हर चार्ज अपनी इलेक्ट्रिक फील्ड बनाता है. तो अपनी अपनी बनाई है, लेकिन हर पॉइंट पे वो दोनों फील्ड कैंसिल नहीं होती. ये एक PYQ है. Two fields do not cancel each other at every point on the dipole axis or on the equator also. So remember, though their charges summation is equal to zero, the electric field due to an electric dipole will be there. So our next section is to learn the electric field due to electric dipole at a point on the axis. Okay. So now we go to the first derivation, actually speaking, of the chapter. The other two concepts which we learned were definitions. This is a derivation using those definitions or the law. Coulomb's law we use, superposition principle we use. Same thing we are going to use here also. We are going to use Coulomb's law here also for the electric field. We are going to use superposition here also to add up the electric field. So now here our topic is field due to electric dipole for a point on the axis. So where is the point? Point on the axis, correct? So let us take a point on the axis. So let us put a point P here. Okay, let us put a point P here. That point on the axis is at a distance R from the center of the dipole. That's why I defined the center of the dipole. O is the center of the dipole. So I have considered one point P on the axis of the dipole with a distance of R from the center of the dipole. Okay? Very important to remember that the point P is considered at a distance R from the center of the dipole. ठीक है? चलो. Now, because we have taken the distance as R from the center of dipole, now we have to decide that what is the distance between the point P and the charge plus Q, because that is our formula in our electric field. K Q by distance square. So distance we have to decide where R is the distance. So distance from each charge to the point we still have to decide. Okay, so here we write down this distance from the positive charge to P. How can we get it? This full distance is R. We know because we have taken it. This portion is A. That also we know because we have taken it. So what will be my distance from P to Q? It will be R minus A. Fine. R minus A will give me the distance between the point P and plus Q. Correct? Similarly, the distance between this negative charge in P, what can we say? Distance between negative charge and P. It will be R plus A. Okay? So, distance between this negative charge and the point P will be R plus A. How did I get R plus A? From here to here it is R. From here to here it is A. So R plus A. Why did I take it in the context of R and A? Because I know R and I know A. That's it. I could have written 2A plus what? R minus A. Again I will get R plus A only. That way also you can see. Clear? So by any way you can get the distances as R minus A from the point P to the plus Q and R plus A from the point P to the negative Q. Now again one query will come in your mind. Why have I taken the point P this side? I can take it that side towards minus Q also. Yes, I can take it. That way also we can do. Right now I have chosen this point P towards the positive charge Q. So I am ready with the distance. So I can write the electric field. Now, as usual, what do? We find out the distance between the point and the charge. We found out. What is the next thing we do? We find out the direction from the point P to the charge or from the charge to the point P. We find out the direction and we name it. So we are trying to find out the electric field due to plus Q at the point P's direction. So we'll again go to our rule. Again we will revise our rule. What is our rule? If the charge is plus Q, then towards the point P. Go ahead from here also. If the charge is minus Q, then from the point P towards the charge. Same rule we will follow. So the direction of the electric field from the point plus Q to the point P is as usual. Start from here. Walk. Go outwards. Walk till the point. Go outwards because it is plus Q. Let me name it as E vector. I am writing here plus Q. You can write E1 also. Why I am writing here plus Q? Because I am indicating that this is the electric field direction due to the charge plus Q. Now, from minus Q, how should I go? From the point P, I walk toward minus Q. Now, here one doubt will come in your mind that in between plus Q is there, let it be. But I am interested in the charge minus Q's electric field. So, how will I decide the electric field of the charge due to negative Q? From the point towards negative Q, immaterial of plus Q in between. Forget it. Mentally, it's there, but forget it while drawing the direction. So I am ready. What name I will give? E vector minus Q. What is this indicating? This is indicating the direction of the electric field due to the negative charge minus Q. Ready. So I am ready with the direction of the electric field due to both the charges. I am ready with the distance also from the charge to the point for both the charges. Correct? So I can write down the values of both these electric fields. Now before that, Let me also note down the direction of the electric field, not electric field, the direction of electric dipole P, which is always from negative Q to positive Q, which I have noted down. Now, to remove the confusion from here, I'll just clean this place. Correct? So here I am also ready with the direction of the electric dipole, which is from minus Q to plus Q. The diagram is ready. I have drawn the diagram in front of you so that in exam there should be no confusion while drawing the diagram. Okay. For a quick revision, let us revise the electric dipole diagram in Hindi. Fine. चलो हमने लिया है एक कॉम्बिनेशन ऑफ प्लस क्यू एंड माइनस क्यू जो इलेक्ट्रिक डाइपोल है. हमें फाइंड आउट करनी है इलेक्ट्रिक फील्ड पॉइंट पी पे ऑन द एक्सिस ऑफ द इलेक्ट्रिक डाइपोल. ये जो पॉइंट पी हमने लिया हुआ है वो डिस्टेंस आर है फ्रॉम द सेंटर ओ ऑफ द इलेक्ट्रिक डाइपोल. ठीक है, तो यहाँ पे हमें इलेक्ट्रिक फील्ड फाइंड आउट करनी है. हमें जाननी है कि इलेक्ट्रिक फील्ड क्या है इस पॉइंट पी पे. तो सबसे पहले हम डिस्टेंस जान लेते हैं पॉइंट पी और प्लस क्यू के बीच, पॉइंट पी और माइनस क्यू के बीच. पॉइंट पी और प्लस क्यू के बीच डिस्टेंस विल बी आर माइनस ए. क्यों? ये टोटल डिस्टेंस आर है और यहां से ये ए है तो ये आर माइनस ये ए, ये मिलेगा आर माइनस ए. डिस्टेंस बिटवीन माइनस क्यू और पी, यहां तक तो आर है, बाकी बचा ए, सो आर प्लस ए डिस्टेंस आ गया. प्लस क्यू और पी के बीच में डिस्टेंस मिल गया, माइनस क्यू और पी के डिस्टेंस भी के बीच में भी डिस्टेंस मिल गया. अब हमें फाइंड आउट करना है इलेक्ट्रिक फील्ड डायरेक्शन पॉइंट पी पे प्लस क्यू की वजह से. तो कैसे करते हैं हम? प्लस क्यू से चलो 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 पॉइंट पी बाहर की तरफ आउटवर्ड्स, सो ई प्लस क्यू. ये है डायरेक्शन इलेक्ट्रिक फील्ड का प्लस क्यू की वजह से पॉइंट पी पर. सिमिलरली माइनस क्यू का डायरेक्शन इलेक्ट्रिक फील्ड का, माइनस क्यू की वजह से जो भी इलेक्ट्रिक फील्ड आया है उसका डायरेक्शन क्या होगा? पॉइंट से माइनस क्यू की तरफ. बीच में ये प्लस क्यू है लेकिन इसको हम फिलहाल मेंटली निकाल देते हैं, ये नहीं है. सो पी तो माइनस क्यू डायरेक्शन वैसे होगा. ठीक है, सो रेडी विथ डायरेक्शन, रेडी विथ द डिस्टेंस. यही हम करते आए हैं और यही हम करेंगे, न्यूमेरिकल्स में भी यही किया है. ठीक है, चलो तो हम लिखते हैं, वी विल राइट E plus Q. Remembering what is the distance between plus Q and P, K. We can write it as K also, we can write it as 1 upon 4 pi epsilon naught also. K, Q upon, what is the distance? R minus A square, whole square. अब यहाँ पे direction, how do we write? See, what is the direction of P arrow? This way. What is the direction of E plus Q, that is electric field due to plus Q? This way. So I will write it as P cap. What is the meaning of this? Direction of electric field due to plus Q is same as the direction of the electric dipole minus Q to plus Q. इसका मतलब ये है. Okay. Now let me write E minus Q. वापस के Q divided by distance square. वापस I should write P cap, but here while writing P cap I will write one negative symbol. Why? Why will I write the negative symbol there? To indicate that E negative Q, that is electric field due to negative Q, is opposite of P vector. ये दोनों एक दूसरे के opposite हैं. To indicate that I have written minus Q. Now, what is the total field or the net field on the charge of the due to the two charges at the point P? What should I write? Using principle of superposition at the point P, I write the total electric field E is equal to E plus Q. Plus, I have to add. My superposition is telling me to add only. So, I will add electric field due to minus Q. Here, we also write what is P cap. What is P cap? It is a unit vector of P vector. That is the dipole direction P vector or electric dipole P vector. Fine. So, I'll just substitute here the values of E plus Q and minus Q as it is K, Q, R minus A whole square, P cap minus, because here I have written minus to show the direction. So K, Q, R plus A whole square, P cap. Now physics is over. Physics खत्म. मैथ्स करना है. मैथ्स करना है तो K, Q कॉमन है, P भी कॉमन है. कॉमन ले लेते हैं. We will take K, Q common. Outside, I can write K as 1 upon 4 pi epsilon naught also. Whole square. Minus 1 upon R plus A whole square. P cap I have written this side just to indicate the direction. Now, here I will do the maths for the convenience. It can be done by everybody. You all are in 12th standard, but I just do it quickly. This is like A minus B, A plus B. So A minus B into A plus B is A square minus B square. R square minus A square within the brackets whole square, because both of them have square. So A minus B, A plus B, R square minus A square. Both have whole square. So I have written whole square, and up I write it as A R plus A whole square, which is R square plus A square plus 2AR minus R square minus A square plus 2AR. Okay, P cap. So R square cancel with this. What am I left out with? 4AR. Now in my next step, okay, so now I continue. E is equal to KQ. What is left out? 4AR upon R square minus A square whole square. Okay, P cap. This can be left here itself, but we can talk about another condition. एक और condition ले सकते हैं जहाँ पे point P जो है is very far from the dipole. So let us consider a case in which R very much greater than E. R बहुत दूर है. Point P is very far from the dipole center itself. O. ठीक है? So in that case, we can neglect A compared to R. Neglect, not zero. I'm saying neglect it. It is there. A is definitely there because we have taken 2A as a distance between plus Q and minus Q. So A we can neglect in comparison to R, where R is the distance between the center of the dipole and the point P which we have taken. Okay, so E is equal to KQ 4AR upon R square square. Now here one more point will come into your mind, that I have not neglected A in the numerator. I have neglected A only in the denominator. Why? A has a value. That's why in the numerator it is there. Denominator, while subtracting, we have neglected it. And that too it's square. Fine? Okay. So finally, we have E is equal to KQ 4A R upon R raised to 4. That will cancel out. So I'll have R cube. I have just cancelled the powers. This power is 1. This is 4. 4 minus 3, I have written that Q, P cap. So rearranging, we write electric field is equal to K, also I write it as 1 upon 4 pi epsilon naught. For A Q upon R cube P cap. So this is the formula of the electric field provided R is very much greater than A, such that we can neglect A in the denominator, in the numerator it is there. Otherwise, the formula of the electric field due to a point on the axis of electric dipole remains this. So as can be seen in both the formulas, whether R is very much greater than A, you can see the electric field and direction and the P unit vector, they are same, because here we have got a positive symbol, here also there is a positive symbol. It means the direction of the electric field and the unit vector P cap for the electric dipole is the same direction. Fine. This is your P by Q. It can come. Fine. The direction of the electric field and the unit vector P, which is the direct unit vector of the electric field or the electric dipole moment, is the same. Fine. Now I will move and you just take a screenshot and learn it. Fine.